we discussed. So I'm going to take you to second level or the next level in threads to identify, are there going to be any new problems associated with multiple threads? So as stated already, we will check the problem, we'll see the problem and then we'll solve it. So can you open? I have already given you. Oh, I have not given you. Sorry. I'll send you. I'll send you some code, ready-made code. So just download it and we'll get started. I'm sending you synchronization.zip. Just download it. I'll give the instructions. You got it? Okay, so once you extract, you will find a class called as bank account. So that you are going to take. Just let me tell you. Let me just check which package P8. Okay, we'll create another package for that. Anyway, so I'll give you the instructions. Let's not spoil the earlier project. So create a new project, 21.2. It is going to be used for synchronization purpose. So day 21.2. And here, create a package here under SRC, app core, standard instructions. And here, after you extract that synchronization, you'll see bank account.class, which is nothing but a joint account. You'll see all of that and paste it under your app core. So after that, you will get a compiler error because the package name is not matching. So simply click on that and change the package declaration to app core. So I'm waiting for you to finish all these instructions. Tell me, all I have done is those who are joined late. I told you still people have not joined to join in time. So anyway, I'm not going to repeat instructions 10 times. So create a new project, create a package app core and copy that bank account and just change the package name suitably. Done? Okay. And now I'll say you refactor. Right click on bank account and refactor the name as joint account. So that later, whenever you are looking at it after 3 days or 3 weeks or whatever, you will know that this was the shared resources problem we are trying to solve. So open joint account and I'm giving you a minute. It's a very simple class which I've written. So read this with the main focus on two methods. One is update balance method and one is check balance method. I'll wait here for a minute. Go through the whole class. It's not a complex class at all. Did you join late, Madan? Because I've already shared it. Share with him somebody. So you should join in time, Madan. Not just you, anyone. Late comers, they don't get this. So please get into the practice of joining in time, please. Yeah, he's got it. Don't keep sending. He's got it already. Enough. Okay, so have you read the entire code, guys? Joint account. Okay, so now start focusing. Don't increase the traffic on the chat group. He's got it, I hope. So otherwise send him on WhatsApp or some other medium. Don't distract me like here. So joint account, let me ask you, what is the state? Which is the instance variable of the joint account? Balance. I have not kept the account number and all that. Our main purpose is uh, finding out the racing condition and all that in the thread. So I've kept it very simple. This is a parameterized constructor. Okay. This is a suitable toString. Nothing complex. The whole code is not complex at all. So now I hope you have read this update balance method. So I have a question for you. Suppose my original balance before the user called the update balance method was, let's say, 5,000. So original balance suppose was 5,000. I'm giving some number. And if I say the amount, okay, the amount which I'm sending to this is 1,000. Okay, simple numbers I'm giving you. Think before you answer. I have not yet asked the question. So if it was a single threaded system, okay, only one customer operating on her or his account, what would be the value of the balance in a single threaded system? If it is operated by one single user, what will be the value of the balance here after the method is over? See, look at the problem with yourself, guys. Are you not reading the code? It is such a simple code. It is such a simple code we are having here. And you are giving me such horribly wrong answers. What is wrong with you? I said, don't think in threads. It is just a single threaded system. So what is the code here? What will be the value? I asked you exactly at line number 26. So tell me, don't tell me increment and decrement. Did I ask you that, Rishikesh? I asked you what is the value of the balance. So why it took you so much time to come at the right figure is beyond me. Don't do this. You have done so many technologies. You are close to appearing for interviews and all that. So guys, you should be better than this. Of course, it is going to be 5,000 in a single threaded system. I never asked you in a multi-threaded system. So what happens here? Balance plus balance equal to amount. So here, of course, you ping, this is 6,000. But suppose I don't have any other threads to cause the racing condition. The thread continues its execution. The updater thread, the customer who wants to make the update, continues. So the customer realizes that, okay, I can't deposit the funds because maybe I've got some, expenses coming up. So this is the think time of the user. Okay, user thinks that, okay, I seriously cannot deposit. So user cancels the updates. So canceling the updates here. So now, was it such a difficult question which you really surprised me, disappointed me, to be precise, when you gave, so many of you gave me wrong answer. So what will be the balance here? Of course, restored back to 5,000. Okay, and that is what is the value here of the balance 5,000. Are we understanding? Guys, you have to do better than this. Don't disappoint me like this. Don't disappoint yourself like this. Okay, strong statements I'm making. So if everyone understands that, if it was a single threaded system, this is getting called as a single piece of block, atomic instructions. There is no collision, there is no interference, there is no racing. So all is good, cool. But now when you bring in two threads, or okay, forget two threads. Let me continue with the single threaded system. Single thread means you have only one customer who is operating on her account. So one customer, let us say, updates the balance, and when she checks the balance, what is the value of the balance she's going to get here? What will be the value of the balance will be returned always in a single threaded system? The balance will be 100% 5,000. Okay, so this is so easy in a sequential execution. But we are past that. Today's topic is, since yesterday we entered the threads, Now you imagine two customers who are owning the same joint account. The joint account has two account holders. And now tell me, now I'm talking about two customers, two threads operating on the same account, same shared account, or different accounts. Same account. Everyone understands it? So we are talking about sharing of resources now. So now tell me, suppose customer 1 is updating the balance. Customer 2 wants to check the balance. Okay, so now start solving. I'm going to show you the diagrams and all that little later. So customer 1 is going to be represented by thread. Have I given you the threads and tasks? No, that we are going to write together. I've just given you the basic code. We are going to build on that. So in a minute, in 5 minutes, we are going to write updater task. The moment I say updater task, will it be implements runnable or extends thread? Implements runnable. I told you that first example only was extends thread. Rest all we are going to use implements runnable. Now tell me, this updater task, listen to the question. Don't give me wrong answer. I take your time. This updater task in its class, in its constructor, is it going to create a bank account instance? Option 1. Similarly, checker task is going to create in its own constructor account instance, joint account instance. Option 2. Option 3, main thread is going to create a single instance of joint account and pass it to these two threads. Option 3. What do you think we are going to do? Everyone is clear? Because I was like worried when you gave me such a horribly wrong answer. I did not know whether I'm reaching you at all. Of course, it is option 3. What are we discussing, guys? Sharing of the resources across multiple threads. So all of you are clear so far? Next. So now your updater thread and one customer who is updating the balance, other customer checking the balance. So now let us say the updater task or updater thread, that customer got a chance first. So what will be the output here? Updating the balance, and we'll give some name. Let us say C1. C1 is the one, customer 1 updates, customer 2 checks, something like this. So if I say, so the name of, we'll keep the name of the threads. It's like a transaction, concurrency and transaction, most important topic in the world. So customer 1, I'll get updating the balance by customer 1. So here the balance amount is 6,000. All good. Now here we are, the customer 1 says, okay, I need time to see whether I really can deposit the funds. So here when you say thread.sleep, tell me what will happen to the customer 1's thread. Will it continue to run or will it be blocked? It will be blocked. Don't give me half answer. Yes, Anshumala's answer I'll accept because correct, I mean most precise. So what will be the status of customer 1 thread? Blocked. On which condition, guys? Blocked on sleep. Okay. So now which threads are runnable? Our main thread is going to be put to join. So waiting for the child threads. So main is blocked on join. Customer 1 thread is blocked on sleep. So which is the only thread which is active, which is runnable? Customer 2. And now when we write that checker task, check balance task, in the check balance task run method, which method you will call? Will you call update balance or will we call check balance? We will call check balance. So now tell me at this point in time, what is the figure? What is the balance figure? Is it 6,000 or is it 5,000? It is a 6,000. Okay. So now tell me here at the same time, because the first one is sleeping or there could be a genuine context switching, you can never control the scheduler. So now tell me here the balance, the checker task will end up getting is 6,000. Okay, so she will happily, or the other customer thinks that okay, I've got 6,000 in my account. Okay, so tell me now So this happens. So tell me, is this the correct output or is it a wrong output? If I get it as 6,000, it is a wrong one. It is the stale data. I don't know how much jargon you know in database. It is called as the stale data, inconsistent data, right? So here, now see the continue with the story. This thread is not dead. This customer thread is not dead. So what is going to happen after 20 milliseconds? Is going to continue or is it going to get aborted? After 20 milliseconds, what will happen? The thread continues. So you know all that. Block to ready, ready to running. And now the customer realizes I cannot really deposit the funds. And what is the true balance of the account? Is it going to be really 6,000 or 5,000? 5,000. I hope your database faculty or in your database training, you have thought of all these transactions. So here, if you see the checker task sees the balance as 6,000, is it a correct scenario or is it a wrong scenario? Wrong scenario. So let us see whether we are actually getting this wrong scenario. And then you will see the problem I have already told you. If we were running it in a single threaded, single customer system, will you ever get this problem? No problem, because the whole method is going to get executed as a single atomic instruction, right? So there is no, context switching at all. There is no confusion, there is no collision, there is no interference. But the moment you expose it to multiple threads, you will definitely see the problem. So in next 10-15 minutes, let us first observe the problems. And I told you, solution is one word solution. Okay, you understood the statements I made? So now you tell me, I have given you the core class. So what is the next step you want us to write? There's no collection, there's no IO. I'm just focusing on the simple things. What should we write next? Any guesses, any suggestions? The threads. Yeah, so the threads, where we are talking about synchronization, have you seen the problem here, Tanshamala? You are going way ahead of time. I want to see the problem, show you the problem first. So the correct answer is write those tasks. So I think I have written it in the sequence. Let me see. Yeah. So here, read this. All this is done. So check balance, return. This I have already explained. So the next step is we are going to write the, you can start writing parallelly or sit back and understand, your choice. So updater task, it will have the run method. And run method, in the run method, we are going to call continuously in a while true kind of a loop. You know, bank accounts update balance method. So we have got that joint account. So we will call update balance. And in the checker task, what method we will call? On the same joint account, we will call the check balance method. Are you understanding this so far? Okay. And now, see, I'm going to do it in a while true kind of a loop, run indefinitely. Because guys, in threads, you may not see the problem immediately, but if you keep running the code for a longer time, maybe after 10 minutes, 15 minutes or something, you might come to see the problem. So we will definitely run it in the loop, indefinite loop, while true kind of a thing, and we'll sit back and observe. So let us go to the next step and write this updater task. Start working parallelly. If you want, you can start working parallelly. So this much is said already. So let's create another package, runnable tasks. And here, this thing, updater task. And which is the interface we are going to implement here is runnable. Okay. Anyone wants to tell me what will be the state, as in instance variable? I'll have to maintain here joint account. Very right, Nidhi. So create it. How many copies of joint accounts would be there in our system, in our application? One or multiple? Single copy. The whole idea is about sharing of the resources. So this is a very practical problem. I always try to give you practical scenarios. If anyone is thinking in projects, For example, let's say your e-commerce. These are the favorite topics. Or let's say your flight reservation, online reservation systems. Anywhere and everywhere, you will have to think about these problems, because your application will be deployed hopefully up in the cloud somewhere, AWS or Heroku, whatever cloud you choose. And then it will be open to the rest of the world. And when multiple people are trying to reserve the same seat, or if you go for book my show type of a site, trying to go for the same movie, same show and same seats, of course there will be a collision. And you'll have to think about, the first question interviewer asks you is about, have you taken care of concurrency? So that is what I'm trying to prepare you for. So coming back to the point, yeah, so you said rightly this one, Nidhi, joint account. And let's say something, I'll call it as joint account itself, a good variable name. So if I don't initialize it, okay, let me ask you, let's write a constructor. Okay, so if I do something like this, I need the complete understanding, proper understanding. If I do it like this, new joint account, let's say balance 5,000, original balance, opening balance, right or wrong? It's completely wrong. That will mean your updater task, that is customer 1 has her own account, customer 2 has his own account. So there's no collision, there's no conflict. So wrong code. So get rid of it. Remove this. Instead, what will you do? Will this be a default constructor or parameterized constructor? Parameterized constructor, and you'll definitely pass it. We'll be creating one instance in the main thread, main method, and main thread will be passing it. I hope my statements are clear. If not, ask. And you can simply initialize it. Okay. So this is for sharing of the resources among, or you can say between, because there are only two threads, between two customers. Okay, so same account instance will be shared between two customers. Everyone clear so far? No confusion? Okay, next one. So this is done. And if I put a SOP, I'll put a SOP. I'll ask you the same question. So in constructor by, which is the thread who will be calling this, thread dot current thread dot get name. What will be the answer here? Updater or main? Of course, main. Till now, we have not yet started the separation, separate flow of control. You know, main is going to call it in a short while. Okay, so now quickly, you can copy it actually, or you can write it. The template, thread started, thread over types. Okay, and here, this will be your actual business logic. We always add intermittent sleep to simulate the practical delay. Guys, this is your desktop-based application, all locally hosted. But when you actually deploy it up in the cloud, you have to keep track of the delays. The user will send the request, then it will hit the database, all of that. So we'll have a lot of thread.sleeps and all. So here I'm just catch all, guarding the code in the exception, wrapping it in this, and I'll say error in whichever thread, the name of the thread. This one. You can finish this on your own. And the error, which error? Okay, so this is your boilerplate repetitive code. There's not even a single piece of business logic I've written. And like I said, if you just do the transaction once, that update balance once, you may or may not get across a problem, and you'll be like thinking happily that things are working, and next time you run the code, you have a problem. So don't do that ever. Do always rigorous testing with the with threads, because threads is all about asynchronous unpredictable behavior, and it is going to depend on the system load and the scheduler and whatnot. So while true, indefinitely running loop. And now tell me, what should I write here? I've already explained. Anyone wants to tell me? Line number 20. I'm continuously doing something in that thread. What is it? Exactly, very right, Nidhi. So this is an updater task which the customer wants to update the balance continuously. Very right. So here I've got a joint account instance as a reference, and I'm going to call the update balance. And let's say I'll take the same numbers. So we will start the opening balance as 5,000, and we are depositing the amount 1,000 here. And if you want to randomize it further, add some sleep. So thread.sleep something, anything. I'm just thinking of some prime number. You always, for the better testing, rigorous testing, change the values of the sleeps also. Let it be completely random. I'll show you random number generation also, so that you can randomize the delay. There's a class in Java, java.util.random, and you can do that later. So this is it. One task is ready. So let me share this code in case you want it. So here 21.2 SRC, the enable task and updater task. Okay. You tell me when you are done. We will continue to checking balance task, checker task. Suggestion, again, I'm saying a suggestion. It's not like a compulsory thing. Even those who are not typing this, you can keep downloading this code and prepare the project, or I can give you the project zip after that, because I want everyone to run this code at least and see the problem yourself. Okay, so this is done. Now tell me, what is the next step? What should we do as the next step? The customer 2, yes. So customer 2 is going to do what? Check balance or update balance? Check balance. So here, since it is again going to be very similar, why don't you copy Control C, Control V, updater task into checker task, or you can say check balance task, whatever. Okay, so just copy, and I'll ask you as always, change or no change types. So just make a copy, start telling me. Look at it carefully and tell me change or no change. No change. Why? Because this is your customer 2 thread. Who is going to call this? Customer 2 was also sharing the account with customer 1. So of course the same. Whole thing is going to be the same. And already Shubham told me which will be the line which will be changed. Line number, please. Everyone knows the answer. Line number 20. So here, remove this, and here simply call that as check balance. So what will this check balance return? Control 1, it returns you the balance. So now, suppose, again I'm asking you, suppose 5,000 is the opening balance, and that update balance, I gave the amount as 1,000. So if the things are all fine, if all is well, then what should be the correct, what is the ideal value, what is the desired value of a balance? I hope you're not giving me wrong answer this time. Thanks. Thank God. So here, of course, it should be 5,000. So if I see the balance as 5,000, problem or no problem? No problem. But that is an ideal value, and we don't live in ideal world and all that. So we'll see the problem as usual and we'll fix it. So here, just make a check. If balance is equal to this thing, okay, let's say not equal to 5,000. Why I'm saying 5,000? Because we're going to hard code. Otherwise, it becomes a little more complex. And my focus is on synchronization, thread safety and all that, locks and all that. So if the balance is not equal to 5,000, is it a undesirable, I mean, unexpected situation, unexpected scenario? So here, that means something has gone bad. Something means what? Rest condition has really occurred. And in this case, we'll just write some error message. Invalid balance. Balance should never be, because my customer one is restoring the balance back to 5,000. So this is definitely invalid balance. And in this case, I really don't want to continue. So which is the method to terminate the entire Java application? System.exit. So here, let's have the exit condition here, system.exit, and you can give the error status. Typically, any error code as 0 is basically healthy, -1, -2. So here, terminate the JVM. Okay. And otherwise, simply continue. And just always make sure that you give the different, values of sleeps, so that to cause the more randomness. And more randomness means more amount of context switching and rigorous testing. So that is the whole idea. So if balances, let me check whether we are done here. I think we are done here. So check the balance. If it is not, terminate. Otherwise, simply continue. I'll send you this. The check balance task also. Now we just have to write a main and try the whole thing. So tell me your gut feel. Is your application going to really run continuously till the eternity types, or is it going to get terminated? What is your feel? Is it going to run continuously, or is it going to get terminated sooner or later? We don't know that, because it all depends. Of course, it is going to get terminated, because like I said, where we have taken care of this thing, race condition, this is the problem statement we are developing. Problem statement takes more time. Solution takes half a second, like kinds. Anyway, so let me not waste your time. Let's write the tester. And here, let's say tester. And what we are testing is, current example is about joint account, but let me give it a global name, generic name, generalized name, testing of shared resources. So if you are developing a railway reservation system, any online bus reservation, railway reservation, flight reservation, or book my show, anywhere you have online reservation, you have to worry about it. If you are developing e-commerce where you are maintaining a shop, and shop has a product and a product has a stock and a quantity, both the customers could be multiple customers, multiple threads can be ordering the same product. So everywhere you have to, you have to think about this. So let me call it as test shared resources. Which is the shared resource in our case? It is currently our joint account. Later it can be a database table. It can be some reservation data. It can be anything. So testing of shared resources. Test shared resources is what we are trying. I hope you understand. We do give time to name the class and all that. So you start telling me, what is it I should do first in the main thread? Because I think you can respond. What should I do first? If it comes from you, it is always best. What should I do in the main thread? Joint account instance. I hope you realize here you don't require scanner, because I'm hard coding the balance. So here, create how many instances of singleton instance. Singleton means one single instance in the entire application. Create a singleton instance of the joint account. Okay. And since our code, this thing, what is it called? Yeah, the run method, it is working on 5,000. I better initialize it to 5,000. New joint account instance to 5,000. Are you understanding the simple math part of it? Nobody is lost in the math part, that why she's using 5,000, 6,000 and all those things. I hope people are clear. Otherwise, your apti faculty will have a shock. So here, joint account is fine. The next is, what is it? Now you have to, as usual, create the tasks. So I hope now by now you got the feel. Create the tasks. Creating tasks alone is not sufficient. So attach tasks to the threads, and most importantly, start the same. So you just have to do that. Yes, very right. So let's have thread. Let's say T1. T1 is not a name of the thread, it's a reference variable name, equal to, which is the constructor we are going to use. Everyone should know it by heart. We've been doing it so many times. The runnable instance, you can say runnable task, runnable target, anything, and the name of the thread. So here we'll have new thread. Since there is some business logic, I'm not using lambda, I'm not using anonymous in a class. And here we'll say new. So this is a customer one, maybe update a task. And what is it you need to pass is the joint account. And let's give that name of the thread as customer one. And similarly, let's create another thread representing concurrency, representing another joint account owner. So P2, same account is being passed, that's the main thing, and customer 2. Are you understanding it so far? The code and the concept and the discussion? Good. So now nothing happens unless until you start the threads. They will be only sitting in the heap, I mean the instances. So T1.start, T2.start, and as usual, let the main thread wait till your operations are over. So main waiting for child threads. Correct? And how do we do this? Using a join. Join includes in the throws class interrupted exception. So tell me, the question which I am asking is not from threads. It is from your understanding of exception handling. So tell me, which is a better way out to remove the compiler error? There are two ways. One is wrap it in a try-catch block, or other option is include it in the throws. So look at my multi-threaded application and tell me, task name I've given wrong. Oh yeah. Thanks for pointing it out. Otherwise, we would have got to do this. We never would have seen this. Copy pasting mistake, typical. Check balance task. Correct? Okay. Yeah. So I did not see the message earlier. Tell me, what I was going to say is, yeah. So what is the better way? There are two solutions. One is throws and one is try catch. Which one should we go for? Which one is better? I'm getting both the answers. Correct answer is throws. Anyone tells me why throws is better? Okay, let me give you a clue. Think a little bit and tell me, is your main thread during join, is it actually going to get the interrupted exception at all? No, Anshumala, you are off track. Off track, all are off track. Akshay, Anshumala, stop, wait. I'm asking you a question. I said, practically speaking, realistically speaking, is your main thread, while it is blocked on join, is there any other thread sending interrupt signal to the main? It's a yes or no question. No. Okay. So in reality, are you ever going to get interrupted exception here? No. So then what is the point in investing time in actual try catch when you know this is an impossible situation? So you can take a shortcut here and delegate it. Okay, but if there was a possibility, there was a chance that some thread is going to interrupt this main thread, then we would have of course gone for try catch. So that's how, I mean, you can justify. So what is it? Interrupted exception. Oh, look at this. I was writing it elsewhere. I should be writing it in the main. I was wondering what. Yeah. And then I'm saying here main over. So I have a question. Are you going to see this main over message once we start running the code? Are you going to see this main over ever like? Answer is no. Absolutely not. Okay. So now start running the code and sit back and observe. So first I will just run it just to check whether things are done properly or not. And like I said, sooner or later, I can't predict, nobody on this earth can predict when exactly. Sooner or later, your threads will come across a running, whatever that, racing condition, and it will be, you run it 100 times. I mean, okay, whatever. So, and 100% of the times, like I said, which transition I can't predict, it will get a problem. So now let me create the zip of the code done so far. And I want everyone, those who are not coding along, I'm not pushing you to code along, but I'm definitely insisting you test it with me, please. So where are we? When I'm sending you the whole project, it just takes you to unzip it and just import it in your this. So at least, you know, you will be with the rest of the class. I've sent you the final copy. Like I said, run it a couple of times. it will go, I mean, it will throw you that invalid balance. And is the JVM terminated? Yes. Everyone got the same output. Some of you could be thinking that all of this is happening due to sleep. Okay. So here, guys, this is yours is not the first batch I'm handling. So I know how a fresher thinks. So here, so go to joint account and comment, don't remove the sleep, comment the sleep. Okay. So now let me ask you a question. Even when you comment the sleep, who is ultimately managing the show? Who is ultimately managing the threads transitions? Is it a underlying operating system? Yes, I got it. So you got it, I mean. So I agree. So isn't it possible you cannot control the scheduler? So isn't there a possibility, a remote possibility, a rare possibility, but a possibility that after this much of a code is executed, at that point the context switching takes place? So which context switching I'm talking about? Running to ready or running to blocked? Running to ready or running to blocked? No answer? Wrong, Shubham. Running to ready. After the sleep is commented, how can you say running to blocked? So wrong. So running to ready. So one thread is customer, one thread is swapped out. Customer two's thread is swapped in by the scheduler because you can't control a scheduler, right? And where you have told the scheduler that this piece of code has to run as a single atomic instruction, you're not told that. So of course, scheduler goes its own way, correct? And now in the middle of the transaction, this is like a transaction. Transaction consists of multiple this. So this is update, this is withdraw kinds, right? So the point is in the middle of the transaction, if this customer to gets a chance, what is the balance he's going to see? 5,000 or 6,000? 6,000, which is totally wrong, and you will see that. Okay. So now run the code again. And you can see that here canceling updates. Okay, so I mean the moment see yeah, don't look at this output. The output can get all mixed up because it is all shared on the console. But you just keep looking at, is the code terminating or is the code not terminating? Tell me, guys. After even commenting the sleep, it has to. You'll say you are forgetting. There is one more pair of sleeves. I know that. Like I said, I've been doing it for literally years. So thread dot sleep, you remove the sleep all over the place. Where is it? And run the code. And you tell me, sooner or later, the application will get terminated. So I'll wait here for a minute. You comment all over the sleeves, all possible sleeves. So now, naturally, the transition is not happening from running to blocked, agreed. But who stops the scheduler? Scheduler has its own free will, has its own mind. So it can do the context switching right in the middle of the code and still spoil the sequence. Getting the error or not getting the error? Tell me. Is the application terminating or not terminating? So everyone is convinced that sleep is not killing it. Sleep is not the cause. I mean, I've said this so many times, so I really hate such questions and the answers. It may not happen. Okay, Aman, why don't you be little observant? Did it happen for the first time? It did not happen. It happens. How can you predict how the underlying operating system is going to come across that racing condition? So if you just run it once, you will be ignorantly, you will be all thinking in a, what do you say, you will be in a like your own, wrongly thinking, happily thinking that my code is working, and you show it to your evaluator and at the same time it fails. So tell me, do you want to write such a code, Aman, which works luckily? Do you want to this thing? Of course, Rajiv, it is going to this, keep the code running and meet me when on Monday and tell me, did it break? 100% it is going to terminate. So don't judge so fast, so hastily. Give yourself time and meet me. Maybe in 15 minutes itself is too much. You don't have to wait for Monday. It is going to break, but like I cannot predict really when. It all depends on your machine configuration, scheduler and all that. Okay, so I've spent enough time on telling the problem. I don't want to waste time. So what is happening is, I hope clear, it is a clear-cut race condition. So tell me, race is happening between which two threads? Which two threads it is happening? Customer 1 and customer 2. So customer 1 and customer 2 are both trying to access the same resource, and the resource is what? Let me ask you. Everyone knows the resource is joint account. So let me ask you an important question. Is it immutable or mutable? Is the state of the resource immutable or mutable? It is mutable. How do you say that? Balance I can update. Where I have made the balance final. So any immutable object, when you share it across the multiple threads, will you have to perform, will you have to add the locking as in atomicity, as in mutual exclusion, or is it not needed? You lost my question. I said, when you are working on a mutable object whose state can be changed, is the thread safety required? Is the applying thread safety, applying locks 100% required? So go back all the way to first week of core Java or whenever we did strings. You remember there is a string class and there is a string builder class. So tell me, what is string an immutable object or a mutable object? Immutable. So let us say you created one string object and shared it across the multiple threads. Will you need to apply the thread safety, or is it inherently thread safe? It is inherently thread safe. Now I think you'll start understanding all these words which we were saying. It is inherently thread safe because once you create a string object, can you modify the string contents? Answer is never. It's a read only. Okay, so finals, I mean the constant things or your immutable objects are very much preferred in your multi-threaded programming. But whereas when you talk about string builder, tell me, mutable or immutable? It is mutable, modifiable, changeable. And so if you share one string builder object across multiple threads, can one thread insert or append? There are methods: insert, concat, delete. Can one thread update the contents of the string builder? Yes. Can another thread read the contents of the string builder? Yes. So one is reading, one is writing. And in that case, will you need to apply the thread safety, or is it inherently thread safe? Of course, you'll have to apply the thread safety. Are you getting me? Same thing. Okay, sorry. There was a third class. Which was the third class? String, string builder, and string buffer. So string buffer is immutable. I'm so sorry, mutable, modifiable, but it is inherently thread safe, because if you open the APIs, if you see the string buffer's internal working, all the methods are synchronized. In short, it has applied the thread safety inherently. So that is what we were discussing all these days. I mean, we were not discussing, I was just telling you that this class is inherently thread safe and this class is inherently thread unsafe. So let me get you back to the point and ask you the important question. In the current situation, our joint account is inherently thread safe or inherently thread unsafe? It is thread unsafe. Everyone agrees with me? So now we have to apply the thread safety, which is nothing but synchronization. So do little bit reading and then we will apply. I told you, or okay, we'll do it the other way. What we will do is we will add the keyword synchronized. I mean, it's just adding a keyword and then let that code be running for a long time. And then I'll discuss, I mean, what is happening internally. Okay, so let us make your thread unsafe API thread safe. So which is the keyword we are going to use here? There is a special keyword called as synchronized, and synchronized keyword can come at the method level also, or it can come at a block level. So first I'm showing you method level. So anyone wants to tell me which is the critical section of this joint account which is prone to racing? Critical section means when multiple threads can spoil the code. Anyone wants to tell me? Update. So here, this is your critical section. Critical section means nothing but the section which is open to race condition between the threads. If the sequence changes, the code can break. See the statements I'm making. If we get lucky, if there is no context switching, there won't be any problem. But if the context switching takes place right in the middle of the transaction, everything, I mean, the code breaks. So here, just add the one keyword. See the beauty of Java, or see the ease of programming. You just add one keyword here, synchronized. So tell me, after you add this synchronized keyword and if you run, will you see the code terminated or will it continue forever? I mean, will it continue to run or will it get what is it called, aborted? Try it out. Let me not kill the suspense. Let me not tell you. You try it out. I hope everyone has added the synchronized keyword here and run this. And I'm telling you, sooner or later, I cannot predict, guys. Code is 100% going to get terminated. Getting terminated. See, if I give you all the answers, then there's no fun. Your brain stopped thinking. It is terminating. So sit back and tell me, you missed something. What is it you missed? Tell me. I'm trying to keep the session interesting. Exactly. I asked you guys, which are the critical sections here? So you just told me there's one critical section. Forgot completely about the other fellow. This is also equally prone to race condition. So how can you just plug? How can you just solve the bug for one critical section when the other one is prone to errors? So here you add, what is it got? It's a method modifier. Add the synchronized keyword. It is always, learn by example or whatever, observe and conclude types, best way of learning. And then run this and keep it for eternity types. I mean, let it keep running. Rajiv, I guess earlier was saying. Rajiv, your earlier code terminated or is it still running without synchronization? I'm curious to know. I'm talking to Rajiv. I hope I'm taking the name correctly. Did it terminate at all or is it still running, Rajiv? Without synchronization, I'm asking. Is left the call? You terminated it. Okay, Rajiv, I'll say this. You keep that version also and keep running it in some other project or some other workspace and definitely tell me on Monday. I just want your understanding. So guys, keep this running and now let us spend time in understanding. So please tell me, has it terminated or is it nicely running? Yeah, I mean infinity is too early to say, but let's say currently at least it is running. Okay, so let me share the readme on synchronization. So where is it? Readmes, readme synchronization. Okay, let me share that. This don't this thing. It stopped. Impossible. If you have done the both the things, it is Ankit. There must be some bug in your code. If both the methods you are synchronized and you have done it later, I'll look at it. Impossible. You have definitely a bug in the code. Check your code. I'll send you this version after a while. So let's see. Where is that file? Java file. And let me send you the readme synchronization. Okay. Because majority is already done it fine. You must have done some mistake. Anyway, open that readme which I've sent you. Have you got this readme synchronization? Yeah, please open so that you know later even when I'm drawing the diagrams and all, this readme will be in front of you and read it. I'm spending so much time here because it is also useful or required in your projects and in your the concept. I mean, the solution of synchronization may change, but the concept is very much required. So read slowly. What is a rest condition? First, you need to understand that. You know that you said, but still good to read. Will you ever suffer from rest condition in a single threaded systems? Never. So it is always between multiple threads. And what is the meaning of critical section? A section, code section, which can lead to rest condition, which is prone to rest condition, vulnerable, is called as the critical section. So like you had given me wrong answer, in joint bank account, which is acting as a shared resource, there are two critical sections. One is update balance and one is check balance. And when we synchronize, when we applied the thread safety to both of them, then only the thing worked. Okay. So now read this slowly. Just keep checking in between, pinging that the code is still running. It has to run. If you have done everything properly, it has to run. And otherwise, there's definitely some bug in the code. Anyway, so to prevent the rest condition, you have to ensure that critical section should it be exposed to multiple threads or should there be only one thread at a time? Of course, one thread at a time as a single atomic instructions, meaning if the single thread customer one is updating the balance, if customer 2 becomes ready to run, or if the customer 2 thread gets a chance, should it be allowed to check the balance or should it be blocked? So of course it should be blocked. So what is it you'll have to do is you will have to lock the resource. So what is it you are doing when you add the synchronize keyword? You are simply applying the lock. Okay, so you have to ensure this. You are ensuring thread safety is equal to applying the lock is equal to, synchronization. So synchronization simply said is applying the lock on a shared resource. So now This is one of the most important statement in the entire readme. So let me start asking you the question, because these are all favorite questions. I don't have to share after that interview questions and interview help. Every now and then, every day, I keep telling you so many things. You just put all these things together and make sure that you are reading it on a daily basis. Opening all these readmes just before a week before interviews will not help you, because you'll not even understand things. So please do the daily reading, little 10-15 minutes reading. Anyway, coming back to the point, let me ask you, is synchronization is equal to applying locks? Is it required in a single threaded system or multi-threaded system? Simple question. Okay, definitely it is required if and only if multiple threads, multi-threading. Now, let me ask you a next question. If suppose we are two customers, you are one customer, I am another customer. You are operating on your own bank account, I am operating on my own bank account. So in that case, is synchronization required? Not required. Why? Because we are not sharing the resources at all. So then 100% concurrent transactions can take place, because you are operating on your own bank account. So I'm doing it on my own. So where there is a conflict, there's a race, there's no race. So if and only if multiple threads are sharing the same resource. Okay. So what are the examples of these shared resources? We have seen so many collections, guys. Array list, linked list, vector. Vector was inherently thread safe. Array list, linked list, thread unsafe. Hash set, tree set, linked hash set, all unsynchronized, all thread unsafe. Hash map, tree map, linked hash map, all thread unsafe. Hash table is thread safe. But thread safe means they have entirely synchronized the whole API, extremely slow. So other things I'll tell you in time. So any collection. Suppose multiple threads are writing to the same data file. Easily you will garble that file if you allow the concurrent access. So you'll have to go to synchronization. Database tables you really don't have to guard, because your RDBMS relational, I mean database management system, whether it is document based, MongoDB or whatever, they do give you locks, shared locks, read locks, write locks. Or if you are sharing the socket or reservation and all, you definitely require to apply the locks. Now the last question, let's see whether you get it. Suppose both of us are sharing the joint account. Okay, two customers are sharing the joint account, but both of them are simply checking the balance. So tell me, is then thread safety synchronization required or not required? 100% not required. Are you getting it? Because there's no conflict. So when it is required, read the full statement. If and only if you have a multiple threads operating on the same resource, and one thread is reading as in accessing and another one is modifying, or multiple threads are updating, one is depositing, one is withdrawing, one is transferring funds, etc., you definitely require to apply thread safety. Are we 100% clear? The statements, I mean, you have already seen the code is working. I'm just trying to explain the concept, because people ask you about the concepts. So how to apply? More than easy, one word answer. What can be easier than that? I mean, I can't think of anything. Like how you have async keyword and all. Async is different. Async is asynchronous, but here is synchronized. So how do you do that? Keyword is synchronized. I have shown you at a method level. Soon I'll show you at a block level. So to avoid this racing condition or to guard your critical section, you need to apply synchronization. All the statements in README are clear so far? Because I'm going to say some more things. Got this? Okay, now proceed further. Another important segment. All these are really important. I'm not just like that written. They are really important for your understanding. So understand that here in Java, when you add a synchronized keyword, you have to understand that where the lock is applied. Okay, it is kind of difficult. Okay, I can manage it. So please open joint account, and when a particular class has got synchronized method. Where is the lock applied? Your choices are at the method level, such as update balance, check balance, or at the object level itself. Answer is, I have already written it in the readme. It is applied at the object level. You'll understand all of this just in 5 minutes. Okay. So now I'll just go through the statements and we are going to draw a diagram. There are already drawn diagrams, but it is better to draw it fresh. So there is a lock, and in Java, we describe the locking using a beautiful concept called as a monitor. You'll know about monitor in a minute. So the lock is equal to monitor can be associated with any Java object. It's not like one Java object. It can be applied to any Java object. Another very, very important statement. So before I explain the statement, let me tell you. This monitor is like a concept, So think of a monitor as a building with an extremely narrow entrance. So how narrow that entrance is? Can multiple visitors pass through this entrance at a time, or can only one visitor can pass through it? Answer is one visitor. Okay, so that is the concept we are going to draw. I'm not going to draw a building. I'm just going to draw a box. Anyway, so that is your monitor. So understand this. When does a thread need to acquire the lock? Meaning, when does it have to enter the monitor, enter that building? The rule is, or the statement is, if and only if it is either calling a synchronized method, which the example we have written currently, or shortly I'll show you synchronized block. So guys, try to relate it to observations you have done. You remember we had just synchronized update balance, and our check balance was unsynchronized. Did it work that time, or did the code abort? Everyone knows the answer. Code aborted, because when you made update balance method synchronized, customer 1 thread had to acquire the lock and then only call the method. But customer 2 thread was free running. It never needed to acquire the same lock. So the whole point was lost. Okay. So that is why that is what is important. So when does a thread, running thread, any thread need to acquire the lock? If and only if it is calling the synchronized method or later synchronized block. Can one thread acquire multiple locks? 100% yes. So one thread is calling one synchronized method, and that synchronized method is calling some other synchronized method on some other object. Multiple locks will be required. And again, I mean, unfortunately, all these are super important statements. So one is blocking trigger, which I have written in that diagram, blocking versus unblocking, and the other one is unblocking trigger. So what is the blocking trigger? Customer 1 is executing the synchronized method update balance. Okay. But because of that context switching, or because of some sleep encountered somewhere, some delay encountered somewhere, the customer thread is swapped out. So which thread will own the CPU? Which thread will have the access to CPU? Quickly, customer 2. But customer 2 is going to call synchronized method or unsynchronized method. Unsynchronized, where are you? We have made both the methods synchronized. Why are you giving me wrong answers? It is also going to call the synchronized method on the same object or different object. Same joint account or a different one? Same account. Okay, so it will have to, so your customer 2 thread will try to acquire the lock. But is the lock already taken, or is it free? Is the object under the lock? Yes, it is, lock is already taken. So now the second thread will be unable to acquire the lock. And what is this condition called? Blocked on the monitor. Or you can say blocked because it could not acquire the lock. We're going to draw this in a minute. This is just a warm-up preparation. So you are vice versa. Customer 2 is checking the balance. Okay. And At the same time, I mean, customer 2 thread maybe is swapped out because of context switching. Customer 1 gets a chance. So tell me, customer 1 is going to call the synchronize method on the same object. So will it be able to update the balance or will it get blocked on the monitor? Quickly, only one answer I got. Will the second thread? Of course, it will be blocked on the monitor. It cannot acquire the lock. It cannot enter the monitor. So that is your blocking trigger. So obviously, what is the thread waiting for? Thread is waiting for some other thread to release the lock. So what will be the unblocking trigger naturally? Lock released. In other words, you can say the gate to the monitor, gate to the building is free. Or in simpler words or in formal words, the moment your synchronized method returns or later when your synchronized block is over, the lock is released and then the second thread. Then again, there is a healthy competition between customer 1 and customer 2 because both will be runnable. So don't be surprised if you check here that sometimes customer 1 might get back-to-back 2 chances for update. It is all decided by the underlying scheduler. And sometimes customer 2 may get back-to-back chances. So that is all has to be understood correctly. But the point I'm trying to tell is, after applying synchronization, will you ever see the racing condition still, or have we solved that problem? Will race condition exist or will it not exist? The racing condition will not be there, and that is a proof of concept. See this, I've been talking, I don't know, I don't count the timings and all, but it is running for a sufficient time and still we are going to keep it running. We still have a diagram to draw. Okay, as the last statement and we are ready to draw the diagram. Again, an extremely important statement. Trust me on this. I'm not saying only for interviews, for your understanding, for writing you want to develop, if you want to develop yourself as a Java developer, you should know all these. So which are the in which all the cases, okay, let me not complicate my English, just let me explain this. If a thread invokes sleep, okay, suppose let us say thread has already acquired the lock. So if the thread has already acquired the lock, is it within the building? Okay, internal. So that is Java heap space. So that is obvious. That has nothing to do with the threads. That is because of your memory problem. RAM is limited. That's why. So now you can run that again, Girish. It has nothing to do with the racing condition. So heap is less. That's why. So coming back, where I was, right. So when you say thread invokes sleep, will the thread be sleeping inside the monitor or will it release the lock and sleep outside the monitor? Inside or outside? Inside the monitor, I've already given. So this is sleep is not the only one. Okay, but when you say sleep, is it going to release the CPU or will it block the CPU? Sleeping thread. It will block the CPU. CPU, I'm saying. Will it be in the blocked state or will it be in the running state? Of course, it will be in the blocked state. So sleep method will release the CPU, but will not release the lock. And likewise, there is another method, join or yield or notify. Notify you don't know yet. Or genuinely. See this. Customer 1 has already acquired the lock and before it could restore the balance, context switching took place, means running to ready. Okay, still, so what it will lose and what it will not lose, your choices are, after the context switching, will it release? Your choices are CPU, lock, both or neither. CPU will be released, but the lock will not be released. So I've given you in writing, like I said, all these are extremely important segments. Okay, so I hope you are now ready to draw. If like Girish pointed, he must be low on the memory or something. If you have sufficient memory, sufficient heap, it will. And this is enough time. So guys, if it is aborted because of that internal error, heap space error, restart the program. It has nothing to do with the synchronization. Okay, so now guys, Open Paint. Let's do it fast, looking at time. Otherwise, will not go ahead. And here, let's start drawing or understanding things. So let me ask you, where the lock is applied. Okay, let me rephrase the question. Okay, I'll give you the title. I would definitely recommend you draw. So testing of, or rather explanation of synchronization. Okay. So currently I'm showing you with the synchronized methods. Later you can have it with the synchronized block also. I mean, explanation is the same. So tell me, what is the state of your main thread currently? Draw the threads quickly. 3 threads you're going to draw. So and write it parallelly. So anyone wants to tell me what is the state of main thread? Dead, alive, blocked, whatever. Main thread is, yes. Yeah, alive is fine. Don't tell me just dead or alive, guys. I expect the answer. What is the state of this? Blocked is not correct answer. I mean, it's not a sufficient answer. Blocked on join. Guys, learn with so many this thing. It is blocked on join, waiting for the threads to finish the execution. So main is out of the competition. There's no race. Main is not entering that race at all. Okay. Now tell me the customer one thread. Customer one thread. Simply say, we don't know whether it is running, ready or blocked. So simply say runnable. Initially, both of them are runnable. So there are 2 threads which are in the runnable pool. I mean, ready pool. Customer 2, let's say runnable. Okay. So this is the starting point. Now tell me, which is the which is the shared resource in our discussion? Which is the object, which is the shared resource? Joint account. And how many copies are we having of that joint account? A single copy. So now think and answer. I already explained the whole statement. So if there is a one single joint account, the lock is associated at the object level or at a method level? Answer is the object level. So now tell me, should I draw? We are going to draw a building. I mean, not a building, a box basically. So should I draw that monitor, or monitor is not coming into the picture? Is monitor, what do you say, applicable here or not applicable here? Is monitor required here or not required here? Answer is required. It is applicable. Anyone wants to tell me why? Why we are thinking in locks and monitors? I've already given you the important statement. Why we are talking about a gate and a lock and a monitor? Quickly. No, wrong answer. Wrong answer. I'm still waiting for the correct answer to pop up on the chat. Why we are thinking about a lock here? Synchronized. There is a synchronized keyword you have used, guys. So a thread, these threads will have to enter the monitor is equal to acquire the lock anytime they want to call that update or a check balance, right? That is why we are drawing the monitor. So drawing a building takes a lot of time. It's anyway a concept. So draw a box here. Think of a box as a monitor and label it, and it has a extremely narrow entrance. Okay. So how many threads can pass through it at a time? Single or multiple? A single thread. So label this as, this is nothing but your lock or the monitor concept. This is all for your understanding. So monitor, or you can say lock, associated with the joint account, with the shared resource of joint account. Okay, so this is it. So now let us start the whole story, whole build up. So this is your pour on condition. None of the threads have yet called the method. Okay, so we'll use different colors, red and blue stripes, to show the 2 different threads. So let us say I can start with that. Okay, so within these, what are the methods? Okay, let me rephrase my question. If any of the threads. So for example, customer thread, if it wants to call the update balance method, will it have to enter the monitor is equal to acquire the lock, or can it call it directly? It will have to acquire the lock, and likewise customer too, because both the methods we have made it synchronized. Okay, so let us start with her. I'm just changing the color here, color of the pen here. So here, let's start. Any discussion you can start. So let us say customer one got a chance first. When I say customer one got a chance first, this is a thread. Thread in the middle of night, think of a run method, because that is the code it is going to call in the running state. And what is it we have written here? You remember the code, joint account dot in that while true and all update. Okay, so now start answering my questions. Update method is synchronized or unsynchronized? S or UN? It is a synchronized method, and any thread has to acquire the lock is equal to enter the monitor the moment it is calling any synchronized API. So now let us have some marker here, and it has to come to the gate of this particular monitor. Now tell me, will it be able to enter the monitor, or will it be blocked outside the monitor? Will it be able to acquire the lock or not? It will be able to enter because the gate is free. Are you understanding it? So show it here properly. Okay, and which is the method it is calling inside? This is the monitor associated with the joint account. So tell me the method name here, that update account, right? So this is the method which is getting called inside the monitor. Understood it so far? Once you draw it and once you visualize it, things becomes crystal clear. I'm telling you from experience, and not my experience with the students, with the freshers I'm talking about. Okay, so now open the code parallelly, and imagine that is why I add the sleep. So suppose, imagine you have added the sleep here, because people, this is a favorite question, sleep and synchronization. So this sleep is simulating the think time. In the practical scenarios, the code is not going to run as fast as in the locally hosted system, right? So now I have a question. When you say, oh sorry, not this here. So now if your thread encounters, let us say, a sleep or a context switching or any delay, you tell me, will it, okay, let us put it down here. So imagine that this was your, what was the thread name? Customer one. And customer one encounters the sleep or context switching. So let's talk about one thing at a time. Let's say sleep. Anyone wants to tell me what will be the state of customer one thread? Suppose it comes across some sleep, thread.sleep. It will be, now you are realizing it and answering me so well. Of course, blocked on sleep. But that's not a complete answer. Inside the monitor or outside the monitor? Lock released or lock acquired? Inside the monitor. See the simple concept of a monitor helps your thinking so much. Blocked on sleep, inside the monitor. So has it released the lock? Not really. But the moment the thread is blocked, which part is released? Is CPU busy or is CPU free? CPU is free. So now, which was the other thread in your ready pool? Main is blocked on join. So which is the only other runnable thread? Customer 2. So you can change the color if you're drawing it like this, or you can change your pen color, whatever. So now let's start identifying the working of customer 2. So here, customer 2. So now tell me, this customer 2 has a run method, right? And you tell me in that while true and all that, is it calling the method on the same object? Yes. And which method it is calling? Something like check balance. Okay. So the important question is check balance synchronized or unsynchronized? Synchronized. And any thread, whenever it has to call the synchronized method, does it have to acquire the lock or can it call the method directly? It has to acquire the lock. And so in the other words, does it have to enter the monitor, or without entering, can it call the method? It has to enter the monitor. So now tell me, monitor is associated with the object. So are we sharing the same object between the two threads? Yes or no? Yes. So in short, does this thread have to come to the gate of the same monitor, or a different monitor, or no monitor? Three options: same monitor, different monitor, or no monitor. Same monitor. And now it is obvious. Can it acquire the lock, or is lock already taken? Lock is already taken. The gate is blocked. Can you visually see this? So now you tell me what will be the, I'm writing it here because I have space here. Anyone wants to tell me what will be the state of customer 2 thread? Let me see. Blocked on monitor. Very good, guys. So here, this is going to be blocked on monitor. What is the meaning of this statement, this phrase? Unable to acquire the lock. Blocked on monitor is equal to unable to acquire the lock. Are we understanding it so far? Completely? Kind of. I mean, okay, 100% is too much, but 50% at least, 10% at least. Okay. So now just step back and see the situation. Main is blocked on join. Customer one thread, cust one thread is blocked on sleep. Cust two is blocked. So what is such a condition? Classic deadlock. So are we having, you know the word deadlock? All the threads are stalled. All the threads are, I mean, nothing is happening. So tell me, is it going to stay as a deadlock permanently, or is it going to move ahead? Do you see the thing? Just observe. Is the code running? Of course it is running. So of course there is no deadlock, permanent deadlock kind of thing. So can you tell me what will be the next trigger? What can happen next? So I'll give you the choices. Main unblocked, customer unblocked, customer two unblocked. Which one? Take a pick. Let me see. Yes. So the only thing which can happen is the sleep over, or context switching happens once again, whatever. So now tell me, once the sleep is over, that's why, I was explaining with sleep, things become so easy for understanding. So now go to the code. So sleep is over. What was the value of the balance here? 6,000. But has the checker task, checker thread, customer 2, has it got a chance? No. It is waiting, or it is blocked outside the monitor. So it will complete its sleep. And after the sleep is over, it will get the next chance. It is resetting the balance back again. You will see the message, updations over. And now the most important question. What is happening here? Your thread is returning from the synchronized method. So show it in the picture. So here, now the synchronized method returns. Okay, or rather I can say the thread, this has entered the monitor. Now the thread is returning from the synchronized method. The moment the synchronized method is returned, will the lock be released, or will the lock will be still held? Of course it will release the lock. Okay, so the monitor is free. Don't jump ahead of it, go slow, because this is the place where most beginners make mistake. So now let's identify, write it. I know it is painful to write each and every word, but do that for your own good. So customer one, it is unblocked. I am so sorry. Customer one, let's say returns from the monitor. Okay, mon is for monitor. But can you tell me what will be the state of the cust one? Think and answer. Cust one. Dead. Ragini, we are saying while true. So how can you say dead? So safe bet is runnable. Because you don't know whether it is going to get back to back another chance, which will make it running. Or is it waiting in that ready pool? So best answer is runnable. Okay. So I hope you got this. But that's not a real question. Real question is, anyone wants to tell me, okay, you want to change? Anyway, I'll not change the color. I was going to change it to blue. Forget it. So now, cust2 poorly poor guy was waiting for the lock to be released. So the moment the lock is open, the lock is released, monitor is free. Is it going to stay blocked or will that be unblocked? Of course, unblocking trigger for a thread which is blocked on monitor is monitor becoming free. So cus2 is also, I can't say returns from the monitor, it never entered the monitor, is become runnable. Runnable means goes to the ready pool. And again, there is a competition between a cust1 and cus2 and the whole sequence continues. So what I'm trying to say is, don't be shocked, don't be surprised if cust1 again gets back-to-back chance, and in your output, if you see update balance happening twice or in consecutive manner, it is all decided by the scheduler. But will you ever see the balance, wrong balance, invalid balance? Absolutely not. Because by the time customer 1 is doing its transaction, doing its updation, customer 2 cannot disturb it. And if you play the story otherwise, as in customer 2 got a chance, it is in the monitor calling the check balance. Now customer 1 becomes ready, but can it acquire the lock which is already taken? No. Means what? While one customer is checking his balance, can customer 2 disturb it? Absolutely not. And that is when we say we have applied thread safety, or that is what is nothing synchronization is. Understood 10% at least? 100% is too good to believe, but okay, I'm happy if you are thinking that way, and I'm telling you, solve more code samples and all these things and you'll soon reach there. Okay, and like I said, this is continuously running. So the only way to stop this whole business is abort. You remember we have done that while true kind of a thing. So this is about your applying thread safety is equal to synchronization. So yes, finally. So I think this requires a break. So before, what is it? Do I need to share anything? Yeah, I can share this diagram if you want. There are already drawn diagrams like this, but anyway, fresh one. In case anyone has not drawn it, this is what? Synchronization whiteboard. And you just, I'm giving you a 10 minutes break, about 10 minutes. So, okay, Rajiv, I'll just talk to you in a minute. Thanks for updating me. Thank you so much. So others also get convinced that I'm not trying to fool you or anything. I have a statement to ask you. I have a question to ask you. Okay, I've sent you synchronization whiteboard. So tell me, Rajiv, not just Rajiv, there's nothing personal, you know that. So tell me, guys, you are a budding programmers, developers and all that. So would you like to write a code? If there is already a bug in the code, would you like that code to fail immediately, like very fast in 1 or 2 minutes? Or would you like to keep running it for like say days, and just about you are going to demonstrate it to your boss, it fails? Which is the better situation? Fail fastness. You remember fail fast behavior. If it has to fail, let it fail fast so I can debug the code fast. And guys, that is why I insist on adding intermittent sleeps. Sleep is good for health, as you know. It is excellent for causing noise, or what is it called, randomization in the code. The moment you add some intermediate sleeps, and that too with sometimes prime numbers and all, your scheduler will be forced to do the context switching. It will have to block the current thread, put it to blocked state, and it will have to bring in some other thread. More number of context switching, 100% your code has to undergo rigorous testing, acid testing. So that was my justification. Anytime you are testing small statement, small thumb rule or programmer step, add intermittent sleep. And if the code is working fine for a reasonable time, with the sleeps also, I'm telling you, even when you deploy it in cloud or AWS or whatever, and when you have a client concurrency, lot of client concurrency load, it will still not fail. So this is, this definitely needs a break. So let's have a 10 minutes break and resume in 10 and continue with some more synchronization samples. We'll resume in 10. output and actual diagrams and all. Now all these statements will start making more sense. So we have looked at the keyword synchronized and we have added it at the method level. But there is another way also you can apply synchronization. I'll give you analogy. Everyone knows comparable, natural ordering, comparator, custom ordering. So let me ask you a question. If you are using a natural ordering, where do you have to add the sorting criteria or the comparison criteria? Within the user defined type or outside? I mean, external or within? Inside the UDT. Everyone knows that. So that is what we generally resist. We just keep it for some key based criteria and all that. But all other times, when you go for custom ordering, where do we supply this comparison function or sorting criteria? Within the UDT or outside? It is outside. So I've shown you all the things in last week or whatever. It could be written in a separate class or anonymous inner class or lambda. Everyone knows that. Likewise, synchronization can be done from within, which is called as inherently thread safe code. So let me ask you a question to see how much you have understood it. So this version of joint account class, what will you call it as? Inherently thread safe code or inherently thread unsafe code? You're still calling it as thread unsafe code. Guys, come on. That means the whole discussion of what we spent of whatever 30-40 minutes is all wasted. Here, will you ever see the resting condition? Will you ever see the problem that when one thread is updating, other thread is going to check it and vice versa? So what is it now? The moment you add the synchronized APIs, synchronized methods, what does it make your class? Inherently thread safe or inherently thread unsafe? In short, you have already taken care of the locking. That is what I meant. Okay. So this was my starting statement and that itself got like shot up. So this is thread safe class. But I'm saying you come across so many APIs, not only Java APIs, some third-party codes and also third-party jars and all, where they tell you that this API is thread unsafe. So when you see a warning or a readme that this particular class or this particular API is thread unsafe, you tell me what do you expect to see? Synchronized methods or no synchronized methods? Do not understand? Answer is no synchronized methods. Okay. So I'll take an example. Here, the most famous collection classes we have is ArrayList and HashMap. That is where we spend most time. So tell me, is ArrayList inherently thread safe? No. So we never came across a problem because where we had shared one ArrayList object across multiple threads. So we were like lucky, we were kind of safe. But the moment you are sharing a single ArrayList object across multiple threads and one thread is adding the data to ArrayList and one is attaching the iterator, do you expect the application to work or do you expect it to fail? Of course it will fail. Do you remember an exception called as concurrent modification exception, guys? Okay, 100% you will get that. The moment you have that coming up as an assignment of today, lab assignment. So I'm giving you some thread unsafe code and you have to apply the thread safety. So ArrayList class is already written by Java, guys. So you cannot open that class and apply thread safety. So is there any way to apply the thread safety externally? Meaning, is there any way I can use that ArrayList or HashMap or a hash set inherently thread unsafe API and read it or use it in a thread safe manner? Answer is yes. And that is where you have a synchronized block. Okay. So it's another popular question. Why? What is the need of synchronized blocks? Okay. There are two reasons behind. Okay. read the second reason first, because that is what I was talking about. Read it carefully, read it slowly. So are you going to say that I will never use string builder, array list, hash set, hash map in a multi-threaded environment? You can't. You'll have to use it. But on other side, on the other hand, they don't have the synchronized APIs. So can I use some mechanisms to apply the thread safety externally? 100% yes. That is what is the next topic. And now this is what you are going to see in advanced Java. So let me not give you the example from advanced Java. You might feel lost. But let me say this. Suppose you have written, let's say 1,000 line long synchronized method. I'll repeat my statement again. You have written a really long method added with the keyword synchronized. So while one thread is calling that synchronized method, can any other thread call any of these synchronized methods, either that same or any other method, synchronized method on the same object? Or will they get blocked? Answer is they will get blocked. And actually speaking, in that long code, the real racing condition, actual critical section could be just only 10 lines. So for guarding those 10 lines of a code, aren't you increasing unnecessarily the extent of the lock? So tell me, the moment you increase the extent of the lock, what will you get? Better performance or a bad performance? Of course, poor performance. Everyone gets it. So you will see throughout advanced Java, or I mean, I can't say throughout because whenever, but so you will see that instead of relying on synchronized methods, largely we will use synchronized blocks. So what is the philosophy? What is Java's philosophy? Java's philosophy is they give you largely earlier they were thinking differently, then they realized their mistake. That is why I told you guys, don't use string buffer. It is inherently thread safe, extremely slow. Instead, drop-in replacement is string builder. So they give you thread unsafe API. You as a developer, you be smart, identify the critical section and wrap it in the synchronized block. So that is what we are going to do. Of course, with an example. Okay, so first understand the syntax and then we'll make the code changes. So what is that synchronized block syntax? Extremely easy. Keyword is the same. So you have the same keyword synchronized, and as an argument to the block, you have to ask yourself whose methods you want to call, which objects method you want to call in a locked manner. In short, shared resource reference. So what is the shared resource example in our current discussion? Which is the shared resource for us now? A joint account. So the argument will be joint account. And then you can happily as in safely, securely, security is a different word, but thread safe manner, you can access the methods of shared resource in a completely mutually exclusive or atomic manner. Okay, so there are a lot of statements, there are a lot of things I've said, but basically let me first show you this syntax. So now I'll give you the instructions. So what we are going to do is, first close this. We are going to replace synchronized method or inherent thread safety by the external thread safety. In simple words, synchronized methods we are going to replace by synchronized block. Is the objective clear? Is what is going to be done is clear? Internal thread safety, inherent thread safety by external thread safety. So make a copy, please. 21.2 into 21.3. I mean, you give the name of the class. And now open your joint account. First say Control-Shift-W. Otherwise, you'll mix up. Close all earlier stuff. Open that joint account and tell me, will you continue to add the synchronization here? I mean, will it be inherent? Do you want it as an inherently thread safe or external thread safety? Synchronized methods or no synchronized methods? External. So open that and get rid of this synchronized keyword. I hope you are understanding. See, the concept takes horribly long time to understand, but the application is so easy. So here, remove that and just confirm whether we are back to problem. So just run it from the latest project, tester, run your test shared resources, and within sooner or later, as I keep saying, it will fail. You can't predict when it will fail, but like I said, sooner or later it fails. Are we back to aborting the code again? Okay. So now imagine that this bank account class was given to you. This joint account class was given to you. You have downloaded it from the net in the form of a jar file. Everyone knows jar. So you have so many jars. You'll use so many jars. I mean, if you decide to take a project in Java and all that. I'll give you an example. In your web application, typical requirement is sending OTPs, sending SMS. Are you understanding what I'm saying? I'm just talking about project for a second. You might want to send the OTPs or sending SMS. And when I take you to advanced Java J2E, there is no library in Java. J2E libraries doesn't have it. So you will have to definitely download the additional jars and use those APIs. Okay, so I just gave you an example. There is nothing which is out of box present, but there are people who have taken care of this, so you can do that OTP generation and all easily. So now imagine that, let me come back on the track. Imagine that this bank account, joint account class is of that type where you have got that jar file and there is a clear-cut instruction saying this code is inherently thread unsafe. Means what? Synchronized APIs or unsynchronized APIs? Unsynchronized APIs. Are we all clear? Are we all on the same page? So now, of course, there is a problem. So can I modify this joint account class? Imagine that you can't, because you have got it as a jar file. You don't have the source code for that. So how can you modify it? I'll give you a real analogy. Are you going to modify your hash map when you start using it in this thing multi-threaded manner? You can't. So we are applying the thread safety externally. So anyone wants to tell me, where would you like? Of course, the solution is synchronized block. So can you tell me, where would you like to add? Where do you think we'll be adding the synchronized blocks to wrap the critical section? Joint account is out of your bounds. So don't tell me joint account. Take some other options. Yes, please. People are saying tester. And I'll keep looking at it. I'm not accepting 2 answers. I want 20 answers at least. People are saying separate class. I don't understand you, Prashant. You'll have to elaborate more. Tester I'm getting. Most of you are saying tester. Wrong. Yes, finally. Guys, you have to ask yourself, okay, let me say, because majority said tester. Tell me, is there any critical section to be guarded here? You are going to wrap your critical sections in the synchronized block. So why you are giving me wrong answer? You have to little bit think. You are going to identify the critical section and wrap it in the synchronized block. Main thread doesn't have a single critical section. So obviously your answer is wrong. And the second time you corrected yourself, and that is your runnable task. So open your runnable task. Anything. Tell me the line number which represents the critical section. It's extremely easy. You just have to, focus on understanding. Line number, please, which represents the critical section. Of course, 20. So this is the statement you are going to guard within a synchronized block. So here, see the whole concept takes a lot of time to absorb. I agree, but the implementation is easy. So how do you write it? You just say syn and control space. It will go for synchronized block. I mean synchronized keyword. And see, every time it may not give you the correct answer. So you tell me, is this the shared resource reference? Yes or no? It is. Everyone knows it. So this is fine. So now you simply take this code and put it inside. So here, is this update balance method? You can say control click. Is it inherently thread safe? Absolutely not. But have we managed To apply the thread safety externally, 100% yes. Means what? Means anytime customer thread gets a chance to run, will it have to acquire the lock is equal to, we have that lock. So will it have to acquire the lock as in enter the monitor to call the update method, or can it directly call it? Answer is of course it has to acquire the lock. So guys, you don't draw the picture again. The whole concept is the same. Whether it is a synchronized method or synchronized block, the whole idea, whole concept, the whole monitor concept, blocking trigger, unblocking, 100% same. It is only the inherent thread safety versus external thread safety. Okay, so we have done this. I have a question. Should I add, suppose I told you, more the sleep, more noisy, more randomization, better chances, faster chances of failure. So uncomment the sleep if you want to really acid test your code, rigorous testing. Now think and answer. If I keep, I'm just asking you, if I keep this sleep method inside the synchronized block, will it enhance the performance or will it reduce the performance? Enhance or reduce? Enhance, people are saying. Guys, suppose if you keep it here, tell me, sleeping thread sleeps inside the monitor or releases the monitor? It sleeps inside the monitor. So you are unnecessarily holding the lock for the extra time. Are you understanding me? So this is the point I want to make. Currently, you can keep it anywhere. It's a classroom example. But if you keep it, the sleeping thread sleeps inside the monitor. But guys, this is a casual language. Don't use casual language in interviews. Some interviewers, if they are open, yes, they will appreciate it. Some won't. So what is the formal statement? The thread which is blocked on sleep. Somewhere I've written in the README, I guess. Thread which is blocked on sleep will not release the ownership of the monitor. And it is not about only, it's not only about sleep. Whether you have said join, whether you have said what is that, yield or notify or context switching, the lock is lock is not released. So this will, if you add the sleep inside, reduces the, degrades the performance. Simple logic. More the extent of the lock, performance is compromised, degrades the performance. So ideally speaking, you should keep it outside, but we are anyway testing it. So let it be inside, outside, doesn't matter. Understood this? Understood the statement I made? I'll send you this in case you are interested in a comment. Okay. So now tell me, if I do only this much and run the code, will it continue to work or will it abort? Aborts or continues? 100% abort. Try it out. Don't trust us anything. Sooner or later, like I said, always, it will abort. Why, please? What is the reason? I think everyone should understand it by now. Yes, please. What is the cause? It is still aborting even after applying synchronization. Why is that? Yes, exactly. Guys, now here you have just taken the care of one method, one critical section you have called it in a thread safe manner. But is there another critical section? Yes, check balance. So let me rephrase my question. In current situation, see, I'm just trying to explain things to you all. In current situation, which of the threads have to acquire the lock? Your choices are customer 1, customer 2, both or neither. In current situation, which all are the threads which will have to acquire the lock? Of course, customer 1. Why? Because which is the task your customer 2 is going to call? Check balance task. Is this any, what is it called? Is it any synchronized API? No. So your checker task can go ahead generally, freely, and check the balance even when you are in the middle of the updation. And that is why your code aborted. So what is the obvious solution? What is this thing? You identify the critical section and put it in a, what is it called? Synchronized block. Okay. But here you have to be a little bit careful. Guys, here. So obviously you will say this is your critical section. Agreed. But here you are checking it also. So till the entire checking is done as a fail-safe condition, fail-proof condition, wrap it so that while you are calling the critical section and checking the balance, no other thread can not interrupt, no other thread can interfere with your work. So here, let's have this because I have seen, see, all these are the answers of observation. If you just got this statement, code may keep running for an hour or two. But we don't want that. We want it continuously running. So let's not take chances. So how do you add it? Everyone knows the answer. Synchronized. The argument is fine and keep the whole code inside. I'm telling you, in some cases it works even with one liner synchronized, but in some cases after 10 hours of testing and all, I've seen the code getting aborted because here what can happen is between these two lines, if at that point the context switching happens, then there can be errors. So now tell me which all threads will have to acquire the lock to execute the APIs. Customer 1, customer 2, both or neither? Answer is both. Okay. So now run this again. And again, you can run it for longer time. Don't just check that, okay, if it is working for 10 seconds means it is working. Don't be such hyper. Don't be such a, what do you say, whatever. Like, let it run for longer time. Observe and conclude always. So is the concept of synchronized block clear? Understood the need of the synchronized block? Anyway, I'll wait. Is it working? Is it running currently at least? So 20 point whatever, no, 21 point. I'll give you, when I say the lab instructions, I'll say open this, revise for this particular thing. So please spend good amount of time in revision. And you have pictures, you have readmes, and you have everything. Okay, so let this keep running. Let me ask you, is it running continuously? Not getting aborted and all that, right? Okay, great. Have you understood the at least the syntax and a little bit of idea about synchronized block, guys? Okay, so let us explore more. Always more code you solve, more code you write, and then you sit back and observe and conclude. That is the best way. So I think I have already shared some code with you. Give me a minute. Ready code. Utils. No, not utils. Synchronization mein hoga. Yeah, utils and synchro utils. Yes. Okay. So let me give you the instructions. I have already downloaded, I've given you, uploaded synchronization zip. And there you are going to copy, we'll create a new project, completely new project. So there you are going to copy this tester and utils. Okay, so take this tester and utils. Don't spoil as in don't mix up in this project. 21.3. Uh, 21.2 was done, right? Oh, it's 21.4 it is, sorry. I'll give you the proper comments and all that in the lab instructions. So create a new one and paste it. Oh, I never copied it, looks like. Control C, Control V. I think we'll have to stop this to make it work. So about this code, it's not allowing me to copy. Yeah, now it worked. So about this, you have a weekend, so you can keep it running for whatever time and definitely tell me like later, much later, that whether it was working continuously. It has to work. If you have taken care of synchronization properly, it has to work. Okay, guys. So have you copied? Can I continue? Two things. One is tester and one is utils. Okay. So now First, you open this whole day is about synchronization. Open synchroutils. Oh, yeah, here you have a random number. Anyway, I'll explain the code along the way. 1 minute just for copy, Shubham. Okay, fine, good. Okay, so open synchroutils class. I was anyway wanting to show you this, but okay, this is the chance. So here, when you say, just take the cursor over random and you'll see the pop-up help. Random is the name of the class which represents a random number generator in Java. Okay, so random is the supplier. It represents a random number generator. So I have created the instance of it. I'm just explaining the code. Okay, and here, if I ask you about test, is it inherently thread safe API or thread unsafe API? Safe or unsafe? Thread safe API. Everyone gets it. So here I put a lot of SOPs because I'm going to ask questions soon. Prepare yourself well on such questions. So enter test and whatever is the thread. We are going to create two threads, T1 and T2. So let's say enter test T1, for example. Now see this. Thread.sleep, everyone understands. So now let me explain. Just take the cursor here. There is a method, there are next boolean, next double, so many methods of the random class. So when you say random.nextInt, this is a bound, upper bound, and exclusive of upper bound. So let me ask you, when you say r1.nextInt 40 is just a number. Can you tell me what will be the range? The random number will be produced between which range? If I say it is, give me the range, Gaurav. 0 to 39, exactly. But sometimes I have seen, if you say thread.sleep 0, sometimes there is a deadlock caused. So here I have, offset the range. So what will be the range of the sleep values I'm producing is 100 to 139. So I'll quickly recap. This is not related. I just wanted you, if you don't like this randomization, remove it and just hard code the sleeps. I'm okay. So here, random class is the random number generator. Here we are producing a random sleep in the range of 100 to 139. All good? All clear? Okay. Now, and of course, I've got a interrupted exception, and here I've said exited test. So let me ask you a question, because that is how we are going to write. So if I create one instance of this shared resource, synchroutils, and share it between two threads, let's say T1 and T2. And suppose T1 gets a chance and it is calling this test method. Can T2 disturb it? Can T2 call the method at the same time concurrently? Or will it be blocked on the monitor? Everyone knows it will be blocked on the monitor. So the same concept, the code samples, I'm just giving you practice. Oh, that's it. Okay, so keep noting it in the points. So if you are noting it somewhere, synchroutils, shared resource, test method, thread safe. Okay, now look at the next one. Don't waste your time. I've just copied test into test me. So tell me, test me. Inherently thread safe or synchronized or unsynchronized? You can see synchronized. Another synchronized method from that, like how we had check balance and whatever, update balance, similar. And again, I'm having some randomized thing, some different delay range, just trying to keep the code as random as possible. Okay, so this is your enter test me, exited test me, lot of SOPs. The third copy, same, but what is the difference? Is it a synchronized method or unsynchronized method? It is an unsynchronized, thread unsafe. In short, if any thread wants to call this test me again method, does it have to enter the monitor as in acquire the log, or can it do it directly? It can do it directly. Clear? So these are the examples of non-static methods. And then there are something called as static synchronized. So this I'm going to leave it to you as an extra, do it on your own types. Anyway, we'll discuss it sometime if time permits. So this is test. What are the method names? Yeah, test, test me, and test me again. So if you are making a note of it, test and test me, synchronized methods, Test me again, unsynchronized. That is all you need to note. Okay, let me just say close everything. And I have given one tester already to avoid the wasting of time. So I'm waiting here for a minute. You take a look at the code and then we will discuss it. This will require easily 2-3 minutes, 5 minutes. I'll stop talking. Okay, let's start discussing it line by line. So I'm not taking the effort of, try catch block. With lambda expression anyway, it is useless. So I just said throws in case there are, see, I'm using joins and system.in.read. Everything will be explained one by one, line by line. Focus here. Don't do anything else parallelly. How many objects we are creating of the shared resource? Easy question to begin with. A single instance. Because you don't require the thread safety if you've got multiple resources. So we have done that. Okay. So here. Now to keep your mind, to keep your brain. See, if you see the same code 10 times, you get addicted and you start understanding without even thinking. But I have to keep changing. I have to keep giving you a lot of practice. So here, is runnable interface a functional interface? Yes. Can it be substituted by lambda expression? Yes, again. So there is a problem with the lambda expression and the anonymous inner class, which I'll explain on a Monday. I don't want to say too many things just before stopping for a weekend. So we'll talk about why I have created it outside and all later. Now solve slowly. I'll highlight the left hand side, thread type of reference. Everyone gets that. Anyone wants to tell me, because this looks little, I don't know, complex or not, but little weird. Which constructor I'm using, which thread class constructor I'm using? What is the first argument and what is the second argument, guys? Runnable, first argument, and the second one is this thing, name of the thread. So instead of creating a separate class, I can create either anonymous inner class, but you know better. Instead of that anonymous inner class public void run, here it is the argument of the run method. Run method is argumentless. So I have to add the parenthesis. And okay, now let me not waste your time. You tell me, whenever this thread T1 gets a chance, see the name of the thread is also T1. I just kept it for easiness, simplicity. So whenever T1 gets a chance, what is it going to do? Continuously. While not exit, that is continuously. Till I say exit equal to true. What is it going to do? Which classes, which method it is going to call? It is going to call your shared resources test method. Understood so far? So thread class, here we have just created a thread. We have not yet started. So how many threads are runnable in the system till line number 19? 1 or 3? 1. 2 is a wrong answer. Right? Just now I said I have not started it. So only one main is runnable. This thread is simply created. Okay, write it down. I thought it was quite clear. It is only in a new state. I said runnable. Here my question. Okay. Now same thing. Should not take you more time now. What is second thread also going to do? Whenever it gets a chance, whenever it is started, is it going to call a method on some other object or the same object? Same object. And are they both calling synchronized API or unsynchronized API? I hope you have noted. Test and test me synchronized, test me again unsynchronized. So you know all of that. So here also it is simply new. So you know multi-threading will not start unless until you start it. So now you know the answer. Now there are 3 runnable threads, main and T1 and T2. Are we all good? So you will see the concurrency. You will see on the output in a minute when you start running it. I have given you some ready-made code here. It is excellent idea to solve the ready-made code to understand more and more. Okay, so that is it. Now here, if you remember earlier code we had written, we had said while true and simple. Here I want to show you more. So after a while, when you get tired, when you get hungry, when you get bored, whatever. So then I'm giving you a choice. Press enter to stop. If you want to stop observation and all, you just have to press enter. So now I've given most of the answers here. System.in.read. Blocking API or non-blocking API? Blocking API. Which thread it will block? Main, already there's the answer. And what is the blocking trigger? Blocked on input. So if you don't press enter, what will be the state of the main thread till you press enter? Blocked on input. So main is out of the competition. You just have T1 and T2 running. You'll see all of that. And now after user presses enter, what will happen? See what I'm doing. I'm giving you a lot of SOPs. So I'm saying stopping the execution of child threads. Is there any kill method in Java? Absolutely not. Is there a stop method in thread class? Yes, but it is 100% prone to this thing, deadlock. So they have deprecated it. So coming back to point, I have just said exit equal to true. Now the exit equal to true, what will be the value of while not exit then? After exit equal to true, what will be the value of while not exit? False. Guys, why are you giving me such wrong answers towards the end? And of course, so this looping will be over. Meaning what? Your run method will be over. And what happens when the run method is over? What becomes to that thread whose run method is over? Thread becomes dead. But just to ensure no orphans, because I don't know how long it will take, say sending the signal and threads actually stopping. Who is waiting for whom? Main is waiting for children threads to finish execution, and finally main over. Is the entire code clear? Because then on that I will start asking you questions. 100% clear? Okay, so you're not supposed to run it because that will tell you the answer. So I'm asking you, when you start running it, till you press enter, which 2 threads you will see working? T1 and T2. So now the real question is, here my real question. So here, for that, let me open that. So here, suppose T1 gets a chance. Okay. So what will be the output? What will be the line on the console? Enter test by T1. So if the output is enter test by T1, now the question is, what will be the next line of output? Your choices are, I'll first repeat the question, be focused. I said, if the output is, first line of the output is, whatever line of the output is, enter test by T1, I'm asking you, what will be the, enter test by T2. There is another thread T2 also. So what will be the option? Option is going to be exited test, obviously, because see, I'm making this thread sleep. But you know that sleeping thread sleeps inside the monitor, doesn't release the lock at all. Are you understanding that? So naturally, will you see the synchronous output or asynchronous output? I mean synchronized or unsynchronized? Synchronized output. Okay, so this was my effort to start. This is the startup. Okay, so now run this, guys. Don't be surprised if T1 gets back-to-back chances, T2 gets sometimes back-to-back chances. It all depends on how scheduler is scheduling it or whatever those delay values are. So anyway, I won't do this thing. You pick up any random sample, so everywhere you'll have anytime T2 gets a chance, entered and exited. You'll never see the other thread disturbing it. And if you see somewhere enter test T1, you will never see a T2 disturbing it. Check on your computer. Pick up, don't go by what I'm saying. Pick up your own things and check it out. You have so many samples. You keep running the code longer. Is it all same? Are you seeing the synchronized output or unsynchronized output in short? Synchronized output. All statements reached you completely? This is because naturally the test method is synchronized and we have spent enough time on that. So looking at time, now let us make the copies. So this copy I just wanted to give you ready-made in order not to waste your time. So now instructions. This is the best way I feel to understand the synchronization. And the write-up. Write-up means explanation is all here. Already mentioned it. Okay, so you just have to match the write-up, the readme to your observation and you all will be good. Okay, let's do this. Copy test1.java into test2. Just make a copy and I'll tell you changes to make. And then I'll ask you the question. Before running, you are supposed to guess the output. Have you made a copy? Open test2.java, please. And just one word you are going to change. So the first thread, let it be as it is. In second thread's run method, call test me. Please don't run it and spoil fun. So the question is the same. Have you done the changes? So check. Otherwise, you'll have different outputs than what I'm saying. So the first thread is calling till you say exit, the test method. Second thread is going to call whenever it gets a chance, test me. So the question is the same. What is the question? Suppose T2 gets a chance. What will be the output? Enter test me by T2. The invoker thread is T2. So what will be the, don't have to remember it here. So what will be the first line of the first means any line of the output? Enter test me by T2. So all I'm asking you is what will be the next line of output? Same things. Exited test me by T2 or can there be any time enter test by T1? In short, the same question, synchronized or unsynchronized? Synchronized. Why? Because both the methods are inherently thread safe. And we have already spent, I think, plus 1 hour, more than an hour in explaining if one thread is calling the update balance method, the lock is associated with the object. So no other thread can call on the same object, either the same synchronized or any other synchronized method. Since you have given me the correct answer, I don't think I should waste time in explaining. Just observe and conclude. Did I run the same thing? How can it say? Oh, it's something I messed up. Did I not save it? I was expecting. Oh, it should have come test me. One second. Did I not change it? I changed it. Oh, I did not run it, I guess. Yeah, I thought, I made a mess. Anyway, you don't make a mess like this. So you can check and pick up any random sample and you can check synchronized or unsynchronized. You can see sometimes T1 dominating, you can see sometimes T2, they are at the same priority. So you can never predict. So I just want one answer. Synchronized output, 100% of you are getting it. Okay. So the point is It doesn't matter whether you are calling the same synchronized method. The lock is applied at the object level. So all other methods, all other synchronized methods on that object are also locked. Is the point clear? Is the same observation everyone getting? Okay, third copy. I think you will guess automatically what I'm going to do. Anyway, let's make a third copy. So copy test 2, or you may not guess. Then this test 3. Make a copy. Copy test2.java into test 3 and let one thread call test here, fine, and let the other one call test me again. Tell me when you are done. One thread calling test, other thread calling test me again. So now, guess what is the expected output? Synchronized or unsynchronized? Of course, unsynchronized. Means what? Means what? Or okay, before means what? At this point, will you see the faster output, faster performance, or slower performance than earlier? Of course, faster. How can you say slower? There's no lock, guys. One thread is free to call the API. Faster performance. There's no lock. Okay, let me say this since you gave me a wrong answer. Which thread has to which thread or threads have to acquire the lock to call the API? T1, T2, both or neither? Only T1. T2 is free running. T2 can just get up and start up and call the method anytime. 100% you will see the faster output. So now let me ask you the same question. If the first line, if any line of output is enter test by T1, what will be the second line of output? And exited test by T1, or can it be sometime enter test me again by T2? It can be anything depending on the context switching. So are you going to see 100 exactly? Unpredictable, can be anything. Just check it out. Best thing is check it out. And I hope you realize the speed has gone up. You can add more sleeps and you can appreciate that really it has gone up or gone down or whatever. So just let it run for a couple of seconds. And when you press enter, check it. Pick up so many samples you have. See, sometimes it is working. I'm not saying it is just a luck-based thing. But here, check this. Check those samples carefully. Enter test me again by T2. If it was synchronized, what should have been the second line after that? Exited test me again by T2. But here you have got a complete unsynchronized output. Exited test T1. Your thread started execution, but your T2, there is no control over T2. It can just come in and go out anytime it wants. So how will you describe this output as? Synchronized or unsynchronized? Everyone is getting this unsynchronized output. Okay. So this is the problem statement. But now the next thing is, I'm not allowing you to make any changes. Okay, what would have been a simple solution? Make this method synchronized. Story over. But I'm saying, suppose this class is given to you in a ready-made jar file format. Can you apply the thread safety externally? 100% yes. And what is that approach? Is synchronized block. So last thing before lunch break, copy test 3. You got a lot of code today to revise into test 4. Test 3 is having an unsynchronized output. Okay. So make a copy and identify the critical section and guard it into what is it called? Your synchronized block. So can you tell me the line numbers which you would like to guard? 18 and 22 is one answer I got. I'm waiting for more. Okay, both of them are saying 18 and 22. I need more answers, guys. There are still 206 guys. Okay, somebody. Answer is 22 alone. Guys, I know you could be hungry, frustrated and all that. This code is inherently thread safe. So do you require to add additional thread safety on the top of it? Absolutely not. That's a trick question people ask you. Okay, so which is the only critical section which is exposed to racing condition is this much. Understood me? Why not 18? Because that code test is inherently thread safe method, guys. Why you require external thread safety? You don't. Okay, so just do that. You can add a, oh, wait a second. Huh? I don't have to add this. Wait a second. While not exit. Yeah, I can add this here. Just click here. And here, let us wrap it in a synchronized block. What will be the argument of a synchronized block, guys? Anyone wants to tell me? What will be the argument of a synchronized block? Util, very right. See, ID can give you anything. Don't blindly trust the ID. You have to ask yourself, what is that shared resource reference? Synchronization utils, util. So, in or otherwise, whose method you want to call in a thread safe manner? Utils method. So do that. Have we done this? While not exit, synchronize util and all that. Yes. And here, run this code and tell me, are we back to synchronized output or unsynchronized one? So let it run longer, maybe throughout the lunch break or whatever, and you pick up any random sample and you will never see it going out of sync. Meaning, if the P2 thread starts executing test me again, there's a lot of delay and all, so lot of chances of context switching. Still, it won't go out of sync. Similarly, likewise, pick up any sample where you are having T1. It will definitely be a synchronized output. So I wanted to cover the daemon threads and all that, but looks impossible. I mean, not stretching it after that. Have you got some idea about synchronization at the end of the day, guys? So you will definitely go through it. And I'll give you something like you'll need time today to revise, I'm sure. So go through the revision and I will just mention an optional assignment in case anyone wants to try it. So like I said, that is optional. And do spend some time in the weekend going through so many things you learned throughout the week, the all advanced concepts. And Monday, since I could not finish the part, Monday I will still take some time, such as user thread, daemon thread. I want to show you inter-thread communication, the most advanced topic in threads. And then immediately we're going to start with advanced Java. So that will be all. See you around. Oh, sorry. Before that, is there having any questions, specific question? You might have forgotten. Yeah, library file. Which library file? This one, Rajiv? I didn't understand. Which library file? Assignment. Which assignment? I have yet to the sample data. Everything I'm going to share. I'm going to put it as this thing. What is it called? Day 21 data, and I'll be uploading it in shortly. Okay. Yeah, everything. Every day we do that. Okay. So no, nothing different today. So that will be all. You'll get this data. I'll just collect this data in next 10-15 minutes and upload it. See you around.